Hello everyone, my name is Mihaela Ștefan. I am a professional services at Infinet Wireless. Thank you very much for taking the time to join our webinar. Today I am going to present to you the Infinet Testing Laboratory from the inside. This is a great opportunity for you to discover a part of the complex work that is being performed at every stage in developing and producing a new device. The webinar will be a little bit different compared to the standard format. First, I am going to play a video to present the laboratory from the inside. Then I am going to introduce you with the team that makes everything possible. And in the end, we are going to have a short Q&A session. This being said, let's watch the video together and I will return live afterwards. Every device consists of several components. The testing process can be divided in two parts, testing the hardware and the software components. The hardware includes the enclosures, the motherboard, the radio module, and the antenna. We pay careful attention to each of these hardware parts. The tests of a future device are developed by our design department and begin with the checking of the enclosures. All enclosures must comply with the specified parameters. The enclosures must properly dissipate the heat in order to avoid overheating the device, must ensure tightness, and have to be resistant to the external environment. The testing program for enclosures includes the testing for tightness and for the resistance to extreme temperatures and their sudden changes. Additionally, the devices are placed in a salt chamber and exposed to a salt spray of a certain temperature and density. Based on the test results, conclusions are drawn about the quality of the enclosure and about its resistance in actual extreme environments. Next, the testing of the boards is performed. The test of each new board begins with the first switch on that takes place on the table. We call it the smoke test. During the smoke test, the board is turned on, a visual inspection is carried out, and the thermal profile is captured. It is necessary to recognize potential problems with the future device. To capture the thermal profile of the board, we use a thermal camera, which has a wide range of fixed temperatures from -20 to +350 degrees Celsius. After the initial check, the board is installed inside the enclosure. The next stage of testing begins with the checking of the power supply systems of the board. The power test program consists of three main tests: the cold start, the hot start, and the on and off test. Thermal chambers are used to create specific external conditions. There are two heat chambers in our laboratory, which have an operating temperature range from -85 to 100 degrees Celsius. These chambers are used for a huge number of tests, from checking the strength of the antenna's cover plastic to testing the device's quality of operation under extreme conditions. During the cold start, the switched-off devices are placed in a thermal chamber at a temperature of -55 degrees Celsius for a day, and then they are supplied with power. During startup, the devices are verified according to the standards 802.3 AFAT and the passive POE. Before each test, the device is additionally cooled for at least an hour. After the cold start has been successfully passed, the hot start tests are performed. Now the boards are heated up to +60 degrees Celsius and warm up for at least a day, after which the devices are switched on. Then the testing of the power subsystem is performed. It usually includes on and off cycles under normal conditions and temperature extremes. The power tests are declared successful if at each stage the device has successfully turned on and the access to the device has been obtained. In case of any problems, they are promptly solved with the help of the board's developers. The power subsystem tests are repeated until all problems are solved. After all power tests are passed successfully, the Ethernet testing begins. The Ethernet tests are carried out in thermal chambers at a temperature of +60 degrees Celsius or more using a traffic generator. After the detected Ethernet problems have been debugged, the cold start is repeated. It is necessary to perform a cold start again after Ethernet debugging because these systems are closely related to each other. It is now time for the first radio launch. Our devices have two configurations available, one with the radio module integrated into the motherboard and the other with the radio module connected to the motherboard. However, both configurations have a common testing process. The radio tests begin with the software installation, which ensures the functionality and the launch of the radio system. From this moment, the parallel testing of the boards and of the software begins. After the device has successfully started, after there is no overheating on the thermal profiles and the radio is operational, the first radio connection is established between two devices. The testing of the radio system begins, having the scope to check the quality, the stability, and the performance of the radio. The devices in the 28 and 70 GHz bands are tested in a separate laboratory. For the first launch of the radio, the Axion 28 and the Quanta 70 devices use a radio link over the air. The radio is adjusted and tuned using the minimum output power, the main goal of this test being to adjust the link with the highest quality characteristics, optimal RSSI and minimal EVM at the maximal possible modulation. For the devices in the frequency range from 2 to 6 GHz, the tests are performed using special cables and attenuators. After the main software debugging, the measurements of the radio characteristics begin. They include the measuring of the power consumption, of the output power level, of the sensitivity, and calculating the dependence of the output power limits on the modulation. The power consumption is measured using an accurate power source that indicates the set voltage and the current that the device consumes. For each new device, the parameters providing maximal consumption are found empirically. However, there are a few parameters that are the same for most platforms. The output power is measured at minimum, average, and maximum values. Special power meters are used for it. For more accurate measurements, some platforms have external sync cables that notify the meter at what moment the output power should be recorded. To measure the sensitivity and to calculate the dependence of the output power limitation on the modulation, a test with a variable attenuator is used, its attenuation range being from 1 to 80 dB. It helps to regulate the attenuation in the test bench with high accuracy and without physical switching. Such a study allows to obtain data on the characteristics of the link with high accuracy and makes the automatic testing possible. Different problems can appear at each stage of the measurement, both programmers and developers being involved in their solution. Only after the device passes all previous tests, it is time for extended software testing. The operation of our devices is based on our own operating system, OneFlex. There are several ways of working using this operating system, in particular through the web interface and through the command line. The functional testing of the OneFlex system consists of verifying the device's basic functions and mechanisms. Examples of such functions are switching and routing, synchronization from GNSS or another accurate time source, the IDFS mechanism, the built-in spectrum analyzer, and the operation of the web interface. Great attention is paid to the testing of the software, which is responsible for the operation of the radio. This involves checking the proper functioning of all the software switches. Those switches are related with the device's operation in various scenarios, such as changing the role of the device, the channel bandwidth, the frame length, and many other. It is also worth noting the debugging of the operation under the influence of interference and the mechanism for avoiding it, instant DFS. During testing, the correct operation of the new software versions is also mandatory. This ensures the transition from an older software version to a newer one, the necessary calibration data, and many other mechanisms that are necessary for the normal operation of the device. After the device is ready for the series production, the implementation of the automated tests begins on the production site. All the experience and the data obtained during debugging and the measurements performed at all previous stages are taken into account and applied for providing a successful competitive end product. I hope you enjoyed the video and you are now convinced about the professional testing performed at the Infinet premises. What I want to mention is that additional to what you saw, we also perform all IP66, IP67 testing, but this was not included because we already discussed everything in the previous webinar called Equipment Reliability and Faultness. As a summary, we performed the wire probing test for protection against dust, the test in a dust chamber, the test against powerful water jets, and the test for immersion underwater. I am now glad to introduce to you the people that are responsible with the work performed inside the lab and the people related to the debugging process. Our team consists of 8 engineers who jointly carry out comprehensive device testing from the first switch on to the delivery of the finished product to the customers. Each of them is versatile and performs the entire cycle of testing tasks, from developing a plan and choosing a testing methodology to analyzing and documenting the obtained results. Let's take a look at the actual persons involved in this process. Mikhail Agapitov is the head of the testing laboratory, its role being to unify and coordinate the people and the work performed in the laboratory. Next, Irina Belova is a senior programmer engineer responsible for creating automated testing systems. Let's now meet Valentin Batanov, who is a senior engineer, and Danil Trifonov, engineer of the testing laboratory. They both carry out the comprehensive testing of the entire line of Infinet products. Next, Antonina Kolesnikova is an engineer that also performs complex testing of the cases and boards of the radio part and performance tests. Ilya Starikov is a programmer engineer responsible for creating systems for testing the devices in the manufacturing line. Egor Konyukov is our test engineer that carries out the testing of the web interface for all our Infinet products. And Milena Ogloblina is our test engineer that performs a full cycle of testing for the Infinet devices. This is our team, and thanks to them, we can be sure that all the products are rigorously and professionally being tested at every stage. This brings us to the end of today's webinar. You can contact us through email or by phone, or just find the information that you need on our website. If you have any questions regarding our webinar, please feel free to write them down in the chat section and I will answer them one by one right now. Thank you very much for your attention so far. Okay, the first question that I have is that we mentioned in the video the testing temperature is minus 75 plus 100, but in the datasheet is minus 40 plus 60 for our devices. Actually, in the video, we said that the heat chamber operates between minus 75 and plus 100 degrees Celsius because it's a standard heat chamber. It's not just particularly designed for the Infinet devices. And we also mentioned that for the cold start, we expose the devices to minus 55 degrees Celsius. And for the hot start, we expose them to plus 60 degrees Celsius, okay? So we do not use the entire range of the heat chamber. We just test against the range specified in the data sheet. And we have another question. That one of the boards is faulty, that takes power became red. What is the main issue? Normally, you should perform some basic debugging using our web interface tools, if possible, or on-site debugging. And if you do not find the problem, you can send the board log and all the logs to our support team, and they can detect if it's a hardware issue or another problem, performance related maybe. But our support team can identify hardware problems from the board log. I'm going now to end the session for today, as there are no more questions. Thank you once again for your time, and I hope to see you again during our next webinar. Have a nice day, everyone.